Hey guys, and welcome back to another video. In this video, we'll be discussing differentiation rules. Alright, so let's get right into it. Okay, so to begin with, let's just start with the basic differentiation rules first. Okay, so these are the basic differentiation rules. So first, we have the derivative of a constant function. So if you have a derivative of c, where c is like any real number, this is equal to 0 for any real c. Okay, so the derivative of any constant function is 0. Next, we have the derivative of a sum or difference of two functions. This is simply the sum or difference of the derivatives. So this is just equal to f prime of x plus or minus g prime of x, respectively. Okay, so if it was f of x plus g of x, then it would be plus in the result, and then if it was negative, if it was minus in the derivative, it would be minus in the result as well. Okay, and then we have the derivative of a constant multiple. So if we have the derivative of c times f of x, where c is a constant, then this is just equal to c times the derivative of f, so c times f prime of x. And this is for all real c. Okay, so these are like the three basic differentiation rules that you need to know. Okay, cool. So now that we have that down, let's talk about the other differentiation rules now. So there's four main differentiation rules that are going to show up all the time in calculus. Okay, so you definitely have to master these. So first, we have the power rule. Okay, so the power rule is basically the derivative of a power of x. So if we have the derivative of x to the n, so the power rule says that this is equal to nx to the power of n minus 1. Okay, and this is for any rational n. Okay, so yeah, that's what the power rule says. And just so you know, the proofs of all of these rules can be derived directly from the definition of the derivative. So if you want to see a video of me proving all these derivative rules, then just leave it in the comments below, and I'll definitely make a video on that. All right, cool. So then next we have the product rule. So this tells us how to find the derivative of a product of two functions. So if you have the derivative of f of x times g of x, this is equal to, so first we take the derivative of the first function, f prime of x, times the second function, and we leave the second function alone. Okay, so it's essentially we're taking the derivative of each function one at a time. Okay, so we take the derivative of f of x, and we leave g of x alone, plus, so now we already took the derivative of f, so now we can leave f alone and then take the derivative of g. So in total, we have f prime of x times g of x plus f of x times g prime of x. Okay, so this is the product rule. And if you have like multiple functions, it's just the same exact idea, right? So if you have like three functions, then you just take the derivative of each function one at a time while leaving the other two functions alone. And you just add all the products. Okay, so this is the product rule. All right, next we have the quotient rule. So this tells you how to find the derivative of a quotient of two functions. So if you have the derivative of f of x over g of x, so this is equal to f prime of x times g of x minus f of x times g prime of x all over g prime of x, or sorry, g of x squared. Okay, so again, in the top, it's a similar pattern to the product rule. We're basically taking the derivative of the function, each function one time at a time. But this time, notice that we have a minus instead of a plus. Okay, so that's one thing to look out for. And then secondly, notice that we have the denominator is squared in the bottom. Okay, so for the quotient rule, there's a specific mnemonic that's very useful in case you forget the formula, because this is probably actually the largest formula for out of any of the rules. Okay, so the formula goes like this. So it's like low d high minus high d low over the square of what's below. So what that means, so low d high, so that means the low function g of x, you're saying that that's staying the same. D high, so you're differentiating the high function, the one on top, so f prime of x, minus high d low. So now you're keeping the high function and you're differentiating the low function. Okay, so low d high minus high d low, all over the square of what's below. So you're squaring whatever is in the denominator. Okay, so that's a useful mnemonic to help memorize the quotient rule. All right, cool. And then we have one more, and this one is called the chain rule. Okay, so this one can be a little bit more complicated, but don't worry, we will explain it all very well. So this is for if you're taking the derivative of a composition of functions. So if you have the derivative of f of g of x, so basically for this one, what you do is you just take the derivative of f, like, and you just like kind of ignore g of x at first, right? So this is equal to f prime of g of x first, right? So you're just differentiating f prime and then leaving g of x alone first. And then you go back and you multiply by the derivative of the inside function. So g of x is the inside function, f of x is the outside function. So then you come back and multiply by g prime of x. All right, cool. And then another thing to note is that if you have more than just like one function, so you have like f of g of h of j of x, right? You just keep going in this pattern, right? So like you just differentiate one layer at a time. So like first you take the derivative of the outside function and then multiply by the derivative of the second outside function, and then third, and then all the way to the inside. So it's kind of like it's almost like a sequence of Russian dolls, right? So you just differentiate one function at a time. All right, cool. So I'll let you look at the board, take this all in real quick. Okay, and so now we will do some practice, some examples. Okay, so example 1. Calculate the derivative. So we have f of x is equal to 5x squared plus 8 times x squared minus 4x minus 6. All right. So right off the bat, you should notice that f of x is the product of two separate functions, right? So we have 5x squared plus 8, that's its own function, and then x squared minus 4x minus 6, it's its own separate function. So therefore, we have the product of two functions and we want to take the derivative. What rule should we use? Exactly, we should use the product rule. So f prime of x equals, so remember what the product rule says. It says that if you have the derivative of a product of two functions, you just differentiate them one time at a time. So f prime of x times g of x plus f of x times g prime of x. All right, so that's what we're going to do here. So you will differentiate our first function first. So the derivative of 5x squared plus 8. And also notice that we have powers, so you must also use the power rule. So the power rule says that if you have the derivative of x to the n, this is equal to nx to the n minus 1. All right, so let's apply all of this knowledge to our current problem. So first we want to differentiate this, right? So we want to differentiate 5x squared plus 8. So the derivative of 5x squared is, by the power rule, you just take this power out front. So we have 5x squared, right? So you're going to multiply the 2 out front and then minus 1. So you get 10x to the 1, or just 10x. Okay? So 10x. Cool. And then what's the derivative of 8? Well, remember, the derivative of any constant is 0. So that's just 0. So this is the derivative of this function. And then we keep the second function. So I'm just going to keep this, simply bringing it down. All right, and then we add the first function, 5x squared plus 8, times the derivative of the second function. So again, we can just differentiate each term one time at a time. So the derivative of x squared by the power rule. So you bring down the 2 and then you minus 1. So you get 2x, right? And then next we have the derivative of negative 4x. So the derivative of x by the power rule is just 1 times x to the 0, right? Which is just 1. So then you really just have negative 4 times 1, which is negative 4. So the derivative of negative 4x is negative 4. And then again, negative 6 is a constant, so that's just 0. All right, cool. So now we can distribute the terms and combine. So if you distribute this, we have 10x cubed minus 40x squared minus 60x plus 10x cubed minus 20x squared plus 16x minus 24. Or sorry, minus 32. All right. And then finally, we can combine like terms. So we get 20x cubed. Let's see, minus 60x squared. Minus 60 plus 16. So I believe that's minus 44x. And then minus 32. So this is the derivative of f. Okay. Cool. All right, let's do another one. Part B. We have f of x equals 6x minus 5 over x squared plus 1. All right. So first, let's notice that we have the quotient of two different functions, right? We have 6x minus 5, which is its own function, divided by x squared plus 1, which is another function. So therefore, we should use the quotient rule. So remember, the quotient rule, low d high minus high d low, all over the square of what's below. Okay. And then we will also apply the power rule to help us find the derivative. So f prime of x equals. So low d high. So we keep the low function. So I'm just going to keep x squared plus 1 d high. So then we take the derivative of 6x minus 5. So derivative of 6x from the power rule, this is just equal to 6, right? Because derivative of x according to the power rule, you just bring this out front and then minus 1. So then you just get x to the 0 power, which is just 1. And then any constant multiple of the derivative of a constant multiple is just that constant times the derivative, right? So we just have 6 times 1, which is 6. And then we have the derivative of negative 5, which by the constant rule is just 0, right? The derivative of any constant is 0. All right. And then minus high d low. So now we keep the high function. So we keep 6x minus 5, and then you differentiate x squared plus 1. So by the power rule, the derivative of x squared is what? Well, you bring the 2 out front, and then you minus 1, so you get 2x. Okay, and then again, 1 is a constant, so therefore its derivative is just 0. And then all over the square of what's below. So we just divide everything by x squared plus 1, and then the whole thing squared. All right, so now it's just a matter of simplifying. So we can distribute the 6 to get 6x squared plus 6 minus, let's see, we have 12x squared plus 10x all over x squared plus 1 squared. I'm just going to keep this how it is for now. So we get 6x squared minus 12x squared, that's negative 6x squared, and plus 10x plus 6 all over x squared plus 1 quantity squared. And in many calc classes, this is a very acceptable form, so I'm just going to leave it like this. If your teacher or professor wants you to simplify more, then obviously simplify more. But for my purposes, and for a lot of teachers' purposes, this should be good enough. All right, cool. All right, let's do another one. Let's do one more. Part C. So now let f of x be the square root of 9x squared plus 16. Okay, so immediately it might be a little bit hard to see what's going on here, like what type of rule we need to apply. But then after a little bit of inspection, you can notice that we can actually just rewrite this as 9x squared plus 16 to the 1/2 power, right? Because remember that square roots and just radicals in general are equivalent to fractional exponents. So this is just equivalent to 9x squared plus 16 to the 1/2 power. And this idea of converting between radicals and fractional exponents, this is going to be a super common practice in calculus. Okay, so definitely get used to that. But now we notice that we have some function to the 1/2 power, right? So for now, I just want you to ignore the 9x squared plus 16. Just imagine that's one whole big variable, right? So then we have that variable to the 1/2 power, okay? And then, so we differentiate that. And then once we differentiate that, then we can differentiate this inside function. So essentially, what I'm trying to say is that in order to differentiate this, you need to use the chain rule. Because we have f of g of x, where, or I'll just say h of g of x, since this function has f of x. So we have h of g of x, where we can say h of x is just equal to x to the 1/2 power. In other words, it's the square root of x. And then g of x is 9x squared plus 16. Right? Because now, if you take the composition of h and g, you get exactly this. And so then the chain rule says that, okay, first ignore g of x and just differentiate h of x. So that's what we're going to do. So we want to differentiate x to the 1/2. Well, we can just use the power rule. Remember, because the power rule works for fractional exponents as well. So power rule is valid in this case. So x to the 1/2, we bring this out front and then we minus 1. So we get 1/2 x to the negative 1/2. So that's equal to 1 over 2 square root of x, right? All right, good. So then, let's see, I will write this over here. So we just saw that f prime of x, so we just saw that the derivative of the square root of x is just 1 over 2 square root of whatever the input is. In our case, the input is 9x squared plus 16. I'll write that here. But then we have to multiply by the derivative of the inside function, right? That's the next step. Because now h of x is taken care of. We already took the derivative of that. So now we have to take the derivative of g of x and multiply. So to take the derivative of this function, it's simple. You just have to apply the power rule. So for 9x squared, we take the derivative, just power rule. So we take the 2, multiply with the 9, and then minus 1. So you get 18x to the first power, or just simply 18x. And then, again, 16 is a constant, so therefore its derivative is 0. Therefore, g prime of x is just equal to 18x. And we're multiplying, so I'll just put it right here. So boom, f prime of x is equal to this. And obviously, you can notice that the 18x and then the 2 can simplify down. So we can get rid of that and make this 18 a 9. So this is our final answer. All right, coolio. But yeah, that pretty much wraps up this video on derivative rules. And like I said, if you guys want to see a video on the proofs of all these rules, definitely just leave it down in the comments and I'll 100% make the video. But if you found this video helpful, please make sure to leave a like and don't forget to subscribe. I'll see you guys in the next video.